A 2016 review reported that obesity is the second strongest environmental risk factor for increased cancer incidence in high-income countries, including the UK, and the third strongest globally. With rising rates of obesity, this is only likely to rise. 13 cancer types have been recognized as having a strong association with obesity, not to mention the fact that obesity causes dyslipidemia and increases risk factor for cardiovascular disease. However, the mechanisms coupling weight gain and lipid metabolism are poorly understood. In today's episode, we dive into our second brain in the gut and how some very clever cells can be harnessed to regulate appetite using a completely natural approach. Welcome back to Coffee Break Science, sponsored by the NIHR BRC Advanced Therapies and Devices theme. Hello and welcome back to Coffee Break Science. Today I'm delighted to be joined by my PhD supervisor, Dr. Madusha Peiris, who obtained her PhD in neuroscience from the University of Queensland in Australia, which is where she grew up before moving halfway across the world to start her scientific career at Queen Mary University of London, which is where we met and also worked together under her mentorship for almost 4 years. Madusha fell in love with the workings of the gut and hasn't looked back since. Throughout her research career, she examined numerous aspects of gut health, including pain, the gut microbiome, and new drug targets. But her passion for nutrient sensing and appetite control mechanisms outgrew other gut interests. And in addition to research, she's also an active educator, teaching both undergraduate and postgraduates, including PhD students at Queen Mary. And she now leads Elcella as founder and CEO, taking the lead in turning her discovery into an impactful weight management treatment and teaching people about the importance of gut health for whole body health. So I'm really, really delighted to have Madusha here for the first episode in this season that is diving into the gut.
That's so exciting. I'm so excited to be the first guest on this particular side of the series of episodes because I do like the gut a lot. I spent a lot of my time studying guts and looking down the microscope at them. So I'm super delighted to be here to talk about it with you.
Thank you so much, Madusha. So it's been several years since you first started your postdoc at the Wingate Institute, which is where I also did my PhD, after completing your PhD in neuroscience at the University of Queensland. How did you end up with Elcella? What were the light bulb moments of your career? Can you kind of walk us through your academic career and how you ended up as a founder and CEO? Because it's an unusual path.
It is, yeah. It's a long story, so that it's a single question, but I'm going to have to answer it in a very long-winded way. But yeah, I mean, so I started my postdoctoral career way back in 2008, not knowing anything about what the enteric nervous system was, and that is the nervous system of the gut. I barely knew what the gut really was before I started actually doing my postdoctoral research. So I often think back and wonder, why was I given this job? I didn't have any background in the gut. I didn't really know what the enteric nervous system was. My background at that point was in multiple sclerosis. That's what my PhD was on. But I think what I did do quite well is convey my deep interest in learning and my deep interest in understanding various scientific kind of fields. And so that was what I was doing in my undergrad as well. I was interested in so many different things in my undergraduate degree. I couldn't really sort of pinpoint my finger in one area, but I was so glad that I made that choice looking back to study gut science, gut neuroscience, because yeah, like you said in the bio, I haven't looked back since. And so I think one of the key parts of the story that is important to tell is my journey was not something that I was planning 5 years ahead. In 5 years' time, I'm going to be here. And in the next 5 years, I'm going to achieve this or that. I really wanted to let the science lead the way. And so I think, that's if you want my advice, I think it's really important to pursue what you're passionate about. And so that's what I did. I used to get up in the morning really excited because I was studying something that I found really quite interesting. And every day was an opportunity to make a new discovery. And there was a lot, and there still is a lot in the gut that we don't know and perhaps we take for granted. And so understanding those little molecular pathways at the very my new level was something I was really passionate about. And so in terms of how do you go from being a junior scientist to developing at that point what I thought was going to be an academic career to then leading a company, it is very much a series of events that were led primarily by data and also the pursuit of finding and driving as much impact as possible. So, you know, as well as I do, we interact with patients regularly, and seeing patients in the hospital for various reasons, all related to gut health and gut issues, it really made me want to do something that could have an impact to actually help these people in some way, whatever way that was. And I didn't know what that endpoint would look like, but it motivated me greatly to see all of these patients who are willing to help us do research and conduct research, and knowing that they, you know, were helpless in their own ways and wanting to get back to better health. And so that was a key motivator. I think in terms of how one makes a discovery, I have to tell you that it is purely accidental. You're just driven by, for me, I was driven by curiosity, simply curious about how things worked and understanding it in as much detail as possible, and just letting the hypothesis drive the way forward. And so from my perspective, I keep going back to this, but it really is about finding what you're passionate about. And I was passionate about understanding what the molecular pathways look like and putting information together from other researchers and other scientific data sets to essentially imagine what a pathway might look like. And I think sometimes scientists get portrayed as being very analytical and binary in the way we think, but actually we have to be creative. We have to imagine what the scenario would look like in a very molecular sense. But even so, you have to imagine what it would be and what the outcome might be, and then test that hypothesis. And so that's essentially what I did, and what I continue to do is imagine what the scenario might be, imagine what the outcome could be if I did this and did that and put all this information together. And that's what led to what is now, when we reflect back, the eureka moment.
Okay. So it was a series of hypothesis-driven events that resulted in your brainchild, the product that is now available at Elcella, being born.
Yeah, absolutely. Absolutely. And yeah, completely driven by trying to understand what's happening and asking what I thought was an obvious question, but no one had bothered asking it, and no one had really looked at answering it in a very human sense, meaning all of our work, or nearly all of our work, has been done in human gut tissue. And that is, as you know, not the easiest way to do things, because it's difficult to get gut tissue. It's not a high throughput system, and there's lots of variability. So you have to take time to look at quite a number of samples in order to get the broader picture. But for us, it was asking those questions that are at a fundamental level. In our case, how are nutrients interacting with our gut? Are they just absorbed? The answer was clearly no. But okay, so if they're not being just absorbed, what are they doing? What's happening at a molecular level? And so those sort of questions led to observations, that led to further observations. And then I think the pivotal question was, surely our gut must be able to respond to more than one nutrient at a time. Again, a simple question. And answering that question was what led to the fundamental discovery that you can stimulate with a specific set of nutrients that bind to a specific set of nutrient sensing receptors expressed on specific types of cells, enteroendocrine cells, L cells, for example, that allow for synergistic release of gut hormones that reduce appetite.
Amazing.
Yeah.
So the discovery is one element of this story, of course, but how was it translating that from bench to bedside? Because that process itself is also super challenging. And now I'm beginning to learn a bit more with my current line of research, but it's not something that's part of a scientist's training to kind of take their discovery, their idea into an actual treatment or product or something that can actually benefit the patients, which you spoke about so nicely. I think that often I certainly also started off as wanting to help benefit patients in some way, but that's not always obvious when you're in the lab doing experiments. And yes, there are interesting findings, but in the papers that we write, we often hint at them, but then most of the time, those hints are not really taken forward. So how has it been? How has the journey been to set up Elcella from your discovery?
It's been a difficult one. It's a tricky place to be because you're absolutely right. You can obtain funding to do fundamental, science in the lab to look at molecular mechanisms, but convincing people that you have enough data, that you have enough certainty in your data that it's going to translate, and that's a really important word, translation, and doing translational science, it is much harder than I think even getting funding for lab-based sciences. And especially when you're a scientist and you're, like you said, trying to make that leap across into essentially clinical validation, clinical trials, it can be difficult. But I have to say, one of the things I've been very fortunate to have landed in is the location. So I have been based at Queen Mary, University of London, and the Blizzard Institute, which is located right next to the hospital, which was fantastic for all the human tissue work that we did. But it also allowed us to get a lot of experience and at least observe how clinical trials were conducted. And within our own unit, we had a clinical trials unit built in. And so it was fate, serendipitous, that all of these pieces of infrastructure and support were right there in the middle of where we were. And so that translation was not that it was easy, but at least we had the resources there to do that. The most difficult thing is to get the funding and to convince people that the risk of failure, essentially, that going from bench to bedside is going to be effective, is the hardest part, because there are more failures than there are successes when it comes to that particular step of the translational pathway. So we were fortunate enough to be able to convince a charity that supported exactly this sort of research where you're at the precipice of going from bench to bedside and translating, and it needed that probably, I think, risk-taking view of a charity to say, you know what, we're gonna put some money behind this. And then because of the way we were lucky enough to have a built-in unit, and we had some experience doing clinical trials, especially Elcella's co-founder and my friend for 15 years, Dr. Ruby Akhtar. She had a lot of experience in working with patients and in clinical trials. And so along with other colleagues in the unit who were clinical trials experts, we were able to cobble together a great team who were small and kept it nimble, but again, fortunate enough to work with the right people in the right place to make that leap into actually in treating people.
Amazing. It's super interesting because I feel like I was kind of with you guys at the time that you were kind of making your discoveries behind the scenes, but I didn't quite appreciate. I worked on the upper GI tract and you were working the lower GI tract. It wasn't so linked. So when I saw the launch of Elcella, I was like, oh my God, like the stuff that they were doing and you were talking about some of the targets in lab meeting. I was like, that's actually resulted in something. So that's incredible. And how does the mechanism of Elcella differ from the GLP-1 agonists that are currently on the market, which we're hearing lots about, things like Ozempic, which are injectables usually used for diabetic patients? Can you talk us through a little bit about the mechanism that Elcella works with?
Yes, of course. So Elcella is a targeted nutrient delivery system based on our patented formulation that's, as you know, taken more than 10 years to develop from the lab to where we are now. And what Elcella's capsules do is they contain a specific formulation of medium and long chain fatty acids, which actually bind specifically to types of, essentially they're locks, if you will, that are present on specific types of cells in the gut. And the specific types of cells we're really interested in and we need to get them active are called L cells. And L cells are really important because they are a powerhouse of appetite regulation, particularly appetite reduction. So L cells store and they release a number of different hormones. They store and release GLP-1, which people know about because of the injectables, but they also release a very powerful anorectic or appetite lowering hormone called PYY. And unlike GLP-1, PYY's only role, as we know thus far, is to act on parts of our brain that regulate food intake, particularly to lower food intake. And so it's a really more powerful hormone at reducing appetite than GLP-1 is. And so the way Elcella works is this patented formulation of medium and long-chain fatty acids are delivered specifically to the lower part of the gut, which is called the colon. And it's about 6 meters down from the oral cavity. So it's a long way down. And to make sure our capsules reach that particular region before they disintegrate and go to work with our ingredients, there's a special coating on the outside of the capsules that prevents it from being disintegrated or being broken down in the stomach. And it travels also all the way down the small intestine until it essentially reaches the right pH, so the right acidity for the capsules to disintegrate and then do their work. And so once those nutrients are in your colon, they're able to find their particular, if they're the keys, they go and find their particular locks, unlock these cells. It excites the gut in general. The gut gets excited by having specific nutrients delivered to it. And that promotes the release of these appetite-lowering hormones, GLP-1 and PYY. And it's that which leads to lowered food intake because you've got the signal in your brain saying you're full. So Elcella works to promote the gut-brain signaling pathways, and it does that from a gut health first perspective.
That's amazing. Super cool. Why do you think people have ignored PYY so far and focused on GLP-1?
Because for the past 20 years or so, since the real discovery of PYY, it's probably been a little bit longer, it's not been possible, and it still hasn't come to market, a synthetic version of PYY. So you asked me what's the difference between Elcella and the injectables. Elcella is releasing your very own gut hormones. We have a normal physiological level. Unfortunately, in obesity, that normal physiological level is significantly reduced compared to somebody of a healthy weight. And so that signal from the gut to the brain is not loud enough, essentially. And so people don't feel full. And what the GLP-1 drugs and even tirzepatide, which is GLP-1 and GIP, another gut hormone that reduces appetite, what they do is they inject an artificial version, and that artificial version is engineered to last a long time in the body. These hormones are not meant to last a long time in the body. They have a relatively short half-life. GLP-1 only sticks around for like 5 minutes.
Oh.
So they've made an artificial version that lasts for almost 7 days. So if you look back and think about what's normally physiological and what's happening with the injectables, I think you can understand why they work, but also why they are associated with a range of side effects.
Okay. And have there been any side effects with Elcella? And have you got any kind of testimonials or feedback from patients, and how do they find it?
Yeah. So Elcella doesn't cause side effects per se. It doesn't cause nausea or vomiting, or, doesn't severely reduce the gastrointestinal motility time, therefore causing disruptions and leading to constipation, for example. It can cause a little bit of bloating. Maybe people find a slight difference in their bowel habits, but that's because Elcella is targeting the colon. It's the home of your gut microbiome, and it's having an effect in that region. And so maybe your gut microbiome are also feeling a little bit of a change, and your gut microbiome produces 95% of the gas that it comes from your gut. So change in the gut microbiome is often associated with those sorts of, outcomes. So for us, it's a good indication that things are changing and things are happening. In terms of what people have told us about Elcella is a minimum 12-week journey. We're not a magic pill. We're not a miracle cure. There's no such thing. If anyone's telling you there is, they're lying to you. And we would not stand by our product if we didn't have all of the evidence that we had scientifically and clinically to talk about it. And from a usage point of view, from a consumer trial point of view, we've done a consumer trial, and over 12 weeks, the average weight loss has been 6 kilos, which is really great. It's gradual, it's healthy, and it's sustainable. And I'll tell you why it's sustainable in a second. And people have lost about, on average, 7 centimeters from their waistline. So they're losing abdominal fat, not muscle. Because unfortunately, all humans, we tend to store fat, which is an evolutionary way of helping us survive in times of famine, around our abdomen. And so seeing that change of weight and waist circumference in that trial was, it was so rewarding. And then we've had people continue on Elcella for the last about 6 months. We've only come to market very recently. So even our very first users have mostly come from our consumer trial, and they've continued to lose weight to reach their goal weight. Some people have lost up to 18 kilos, and it's fundamentally changed their lives. And, there's nothing I could want more than to see that sort of health impact on people.
Amazing. I came across a paper that came out earlier this week from Cambridge, actually, I think in Nature Medicine, that looked at a particular marker, which is called MC4R. And I heard about it for the first time because I don't know much about obesity, but apparently this is a gene that is often mutated in people who have obesity, or it makes people more prone to obesity. And this group in Cambridge, led by Sada Faruqi, found that actually this deficiency has, although people are obese, somehow they are protected against cardiovascular disease, which is the number one or number two thing that is associated with obesity. They were found to have reduced cholesterol, the bad cholesterol, LDL, and triglycerides. So I wondered whether in your work in the lab, you had looked at this obesity gene or other markers, and did you measure what happened to the triglycerides or similar kind of LDL cholesterol as a result of taking Elcella, and was there any kind of correlation either way?
So we haven't looked at MCR4 because MCR4 is expressed in the brain primarily. Our interest was looking at the peripheral mechanisms that dominate gut hormone release, but also gut hormone interaction with the enteric nervous system. And so MCR4, melanocortin-4 receptor, is, yes, absolutely important in creating an obesogenic phenotype. And really what we should remember is that there are many factors that are involved in driving obesity, from genetic conditions or predispositions or mutations to altered diet, to psychologies and emotional eating, et cetera, et cetera. And so obesity and treating obesity is should be a multifactorial approach. And there's no one size fits all. Maybe the injectables think that is the case, and we can talk about why that is probably not the case. But yes, certainly we were focused on the peripheral mechanisms and understanding how G protein coupled receptors involved in sensing particular types of nutrient families, what their role was. So really looking at the relationship between food and that old adage, you are what you eat, it seems to be very true. And perhaps we had an instinct of knowing why that was the case. But certainly what our studies have shown is that we all have these G protein coupled receptors expressed from the stomach all the way to the rectum. Despite your BMI, all of these receptors are expressed. And also, very importantly, the L cells, or the enteroendocrine cells that store and release GLP-1 and PYY and other appetite-lowering hormones, are also conserved across the BMIs. And so the machinery is there. And from our point of view, because we're very targeted and focused on the periphery, it made sense for us to pursue the fact that everything's there, the machinery is there. How can we optimize it, and what can we do in a very clever way, I think. Clever, elegant, yet simple, and non-medicated way to optimize the system. But there are many parts of the system, and we can only treat one aspect of it.
Yeah.
And in terms of cardiovascular endpoints, Elcella is very much an R&D driven company. We came from that, and we're going to continue doing that as well. From our perspective, we have to get Elcella into the hands of many people as possible, and we'll start to see outcomes from them. But we're certainly wanting and planning to do further clinical trials in cardiovascular disease patients to look at their lipid profiles, in obese patients as well, to do longer term studies in a double-blinded placebo-controlled kind of strategy. And we would expect, because if people are losing weight, that is going to change their lipid profile, because it's also changing how they eat and how much they eat of various high fatty foods that would confer a lipid profile that is not favorable.
And it's really exciting that you've got plans of doing more clinical trials and also looking at particular disease modalities like cardiovascular disease. I wonder if there would be any, I wouldn't call Ozempic the gold standard, but it seems like the drug that clinicians are recommending the most. I don't know if that's because the NHS funds it for specific patient profiles or not, but would you have plans to do like a trial where you compare outcomes of patients on Ozempic versus on Elcella, so that you could compare things like quality of life and, patient feedback and tolerability, and also like weight loss and waist circumference directly? And then it would be so amazing to have a natural product that is given to patients via the NHS rather than these injectables that have horrible long-term side effects.
Couldn't agree more. Couldn't agree more. I mean, there is a place for injectables without a doubt, because there are individuals who have significant BMIs, significant comorbidities, where weight loss and rapid weight loss is a clear answer to their numerous health problems. What is worrying from my perspective is the use of injectables for reasons beyond that. Mm-hmm. And I think there are a lot of people who are using it for reasons beyond that. In terms of the NHS, I would love to give patients a solution that is sustainable and long-term. So the reason Elcella is sustainable is because we're not replacing hormones. We're releasing what is already there in your body. We all have it. You could go and change your diet and you could do that, and it would take time potentially. But what we're doing is creating a very targeted way of stimulating and exciting your gut to get back to where it should be. And because we're doing it that way, we're actually solving the key issue. Mm-hmm. And if you look at the data, and there's lots of data to show, as I mentioned earlier, that in obese individuals, the level of gut hormones that reduce appetite is almost half of that of a normal weight individual. It tells you that the gut is a major problem in these people. It's not a willpower thing. It's not a mental, issue. It's simply that the gut hormones are not on the side of these people. And so if they're simply replacing these hormones with synthetics, the gut has not fundamentally changed. And so we have people come to us who have taken injectables and who don't want to keep taking them long term, or they just can't tolerate it. And we say to them, you need to do the 12-week high dose program, because at the end of the day, you may have changed what you look like on the outside, but your gut has not changed. And so until you get your gut to change, and until you get your gut to do what it needs to do to a level of a normal weight individual, you're not actually solving the problem. And so that's what Elcella does. It solves the problem. And the way we work is you start on the high dose, and once you reach your goal weight or you reach your health goals, you actually reduce your dosage by half. And then you stay on that for another 3 or 6 months. And then you do what I'm doing, which is I just take 2 capsules a day, because I know it's going to support my gut health. It's going to help my cells tick over. And your gut, I know so people talk about gut health all the time. It's so important. It's so important. We can tell you as gut scientists, I've spent a long time looking down at microscopes and looking at guts. It's your biggest immune organ. It has its own nervous system that connects to the brain. It talks to the brain talks to it. And so it has a lot of impact on your overall health. So it is really important to look after it.
Absolutely. I miss talking about the gut-brain axis. It's so nice to hear you talk about it again.
It's my favorite axis of all time.
Yeah, absolutely. And it's just an incredible organ that is just so long as well, and how it fits into our bodies.
It takes a majority of your internal space.
Yeah. So what is next then for you guys at Elcella? Do you have any key takeaway message for our listeners?
So what's next for Elcella is to get as many people as we can supported by Elcella. That is our goal. Ruby and I, we talk about this all the time. We're not business people as such. We're gut scientists. And the reason that we're here, creating this business is to actually get as many people supported by Elcella and getting them to a healthy weight that is good for them, and to be able to maintain that and sustain that for their entire lifetime is what we're all about. So we are privileged, and we feel privileged to be in the position to help people in such a way. And so with Elcella, what we want to do is try and get as many people to understand what it is. But also, we love educating. We love talking about the gut and telling people this is how complex your gut is. So looking after it and taking care of it is so important, and really teaching people about the gut-brain axis and how it's bi-directional, etc., is something we truly enjoy. So having this platform to be able to talk to as many people as possible is truly, truly a privilege. In terms of what's next for us, we are, like we said, wanting and about to start more clinical trials. We want to look at how we can support patients who are type 2 diabetics to lose weight in a healthy way, but also because our data shows that we're able to modulate GLP-1 levels, and GLP-1 regulates the release of insulin. Insulin regulates your blood glucose. All of that means that Elcella could also be very useful to supporting type 2 diabetics stay in range of their normal blood glucose levels. We also want to look at cardiovascular patients. We also want to look at liver disease patients to see if we can reduce inflammation, but also reduce weight to, concurrently make an impact on their health. So we have a lot of scientific plans, but we also have a lot of plans to grow Elcella, to take it to the US. We've launched to the US market. We're really excited to help as many people as possible across the world.
Absolutely. I think it could be huge in the US as well. And I think it's really unique that you're using or harnessing the body's own ability to just unlock it and help people along.
And I think what I love to tell people about is the way we're unlocking it, we're doing it through nutrients and a certain group of very specific nutrients, because that's what we as humans have evolved to respond to. And actually the locks that we're unlocking with these nutritional keys are often unlocked using drugs. Pharmaceutical companies make artificial versions. They love to make artificial versions of things. And then they, for these particular locks. And at the moment, there aren't any drugs that can unlock these receptors. And so our view was, why do we wait another 15, 20 years to make these drugs when there's actually a natural way to do it? And we have done it in a very scientific and formulated and patented and positioned in terms of its delivery mechanism manner to get actually what we need, which is to get the gut to do what it needs to do and to do it better, and then to stay healthier.
Amazing. Yeah. All the best. I'm really excited to see what happens with the US launch, and also I look forward to seeing the clinical trial work as well. And thank you so much for your time to come and speak to me and our listeners. I really appreciate it.
It's a pleasure. Thank you so much for inviting me.